Have you ever wondered what keeps a plane's engine running, even if all the power goes out? Today, we're going to dive into a surprisingly simple but absolutely brilliant piece of old-school engineering. It's really the heart of aviation safety, and it answers a huge question. How do you make an engine as fail-proof as possible?
So, let's set the scene. Imagine you're in a small plane, cruising high above the clouds. And then, the pilot reaches over and just flicks the master switch off. Everything goes dark. The cabin lights, the radios, that fancy GPS screen, all black. So what happens next? Does the engine just stop? Are you suddenly in a very, very quiet glider?
The answer, and this is what's so incredible, is nope. It doesn't stop. The engine just keeps humming along like nothing even happened. Propellers still spinning, engines still roaring, you're still flying.
And it's all thanks to this amazing little device that's tucked away inside the engine. This thing is a total powerhouse, completely self-sufficient. It makes its own electricity just from the motion of the engine itself, totally separate from the plane's main battery and electrical system.
That surprising answer, right there, it really gets to a core principle of how planes are designed. Safety through redundancy. It's a whole philosophy that makes sure the most critical things always have a backup plan.
So how does this actually work? Well, an aircraft engine's ignition system is basically its own little self-contained world. It's a completely separate electrical system from the one that powers your lights or your navigation instruments. You can almost think of it as a dedicated, tiny power plant just for the engine.
And this system itself is just ingeniously designed for reliability. See, most aircraft engines don't have one magneto, they have two. And each cylinder doesn't have one spark plug, it has two. Now here's the really clever part. Each of those spark plugs in a single cylinder is powered by a different magneto. You see the layers of redundancy they're building in here?
Okay, but how does a magneto actually create a super powerful spark from just simple motion? Let's get into the mechanics of this thing. It's pretty cool.
So, to put it simply, a magneto is a small, engine-driven generator, and it has one job, and one job only: make a high-voltage spark at the absolute perfect moment to ignite the fuel inside the engine's cylinders. That's it.
So here's how the magic happens. First, the engine itself spins a magnet inside the magneto. As that magnet spins, it creates a magnetic field in a coil of wire. Now, right at the exact moment that field is at its strongest, a tiny little switch, they call it the breaker points, snaps open. That sudden break causes the entire magnetic field to collapse instantly, and that collapse creates this massive surge of voltage, and bam! That's what fires the spark plug.
You know, to help picture what's happening inside that coil, a mechanic came up with a fantastic analogy. Think of the electrons in the wire like they're students just sitting in a classroom. The magnetic field is like a bunch of people suddenly running past the window screaming, "Fire!" All those electrons get startled and they all start running in the same direction, creating an electrical current. It's a perfect way to imagine this invisible force at work.
But you might be wondering, what about when you're just starting the engine, when it's turning over really slowly? Well, that's where something called an impulse coupling comes in. It's basically this spring-loaded device that holds the magnet for a second, then lets it go with an extra fast snap. That snap creates a really strong, hot spark. In fact, that distinctive click you hear when you turn a propeller by hand, that's the impulse coupling doing its job.
This design isn't just clever. It's really the perfect example of aviation's obsession with redundancy. It's all about having a solid, reliable plan B already built in.
And this really highlights the difference between how we think about cars and planes. In your car, if the ignition system fails, you just pull over to the side of the road. No big deal. In a plane, well, pulling over isn't really an option, is it? And that's exactly why planes have two completely independent ignition systems. If one fails, the other one just keeps the engine running.
So if there's one number to take away from all this, it's the number 2. 2 magnetos, 2 spark plugs per cylinder. In aviation safety, that idea of duality, of having 2 of everything critical, is what makes flying so incredibly safe.
This whole power of 2 system gives you 3 massive advantages. First, obviously, is complete redundancy. Second, you get total independence from the plane's main electrical system, which is run by the battery and alternator. And third, you actually get better performance, because having 2 sparks in the cylinder creates a much cleaner, more efficient fuel burn.
This whole philosophy really is the heart and soul of aviation safety. Like one expert put it, the entire industry is basically just built on having a plan B for every single critical system.
But there's a catch. This amazing self-sufficiency also creates a very unique challenge. If a magneto is always ready to make a spark, how in the world do you safely shut it down when you're on the ground?
Okay, so to turn off the engine, your ignition switch sends a signal through a wire called a P-lead, which grounds the magneto. But what if that wire breaks? If that happens, you get what's called a hot mag, a magneto that just can't be shut off. It stays live. And in that state, even a tiny movement of the propeller could be enough to make the engine fire up when you least expect it.
And that is why pilots are trained to shut down the engine using a very specific sequence. First, before they even touch the key, they pull the mixture control all the way out. This cuts off the fuel supply, literally starving the engine so it physically cannot run. Then, only after the propeller has come to a complete stop, do they turn the ignition key to the off position. This makes sure that even if there's a hot mag, there's no fuel in there for an accidental start. It's a huge safety procedure.
The aircraft magneto really is just this incredible testament to the power of smart, redundant design. It's a philosophy that puts safety above absolutely everything else. And it kind of makes you wonder, doesn't it? What other invisible plan Bs are built into the technology we all rely on every single day, quietly keeping us safe?